ለመማር ወደ ትምህርት ተቋም መሄድ ግድ አይደለም። ናሽናል አቪዬሽን ኮሌጅ
ራሳችሁን ከኮሮና ቫይረስ ወረርሽኝ እየጠበቃችሁ በቤታችሁ ወይም በተመቻችሁ ቦታ በኢንተርኔት አማካኝነት በኦንላይን ትምህርታችሁን መከታተል ትችላላችሁ።
ካናዳ ከሚገኘው ኢንተርናሽናል ኤር ትራንስፖርት አሶሲዬሽን አያታና ከእንግሊዙ ኢንስቲትዩት ኦፍ ኮመርሻል ማኔጅመንት ICM ጋር በመተባበር የሚሰጡ ትምህርቶችን ተከታትላችሁ በ6 ወር ጊዜ በዓለም አቀፍ ደረጃ ተቀባይነት ያለውን የስልጠና ማስረጃ ባለቤት መሆን ይቻላል።
ልምድ ባላቸው መምህራን እየተማራችሁ ጥያቄና መልስ የክፍል ስራዎች ፈተና መፈተን ክፍል ውስጥ እንዳላችሁት አይነት በኦንላይን ባላችሁበት ቦታ ከናሽናል አቪዬሽን ኮሌጅ
የናሽናል ኤርዌይስ እህት ኩባንያ
ታስታውሱት ቻፕተር 3 ማለት ነው። ቻፕተር 2 ላይ ዌይት ኤንድ ባላንስ ቲዮሪ አይተናል። ቲዮሪ በዌይት ኤንድ ባላንስ ጀርባ ያለ ቲዮሪ ማለት ነው። we have explained about the theory weight and balance and የተለያዩ ምሳሌዎችን በማስጠት ምን weight and balance እንዴት ሊሰራ እንደሚችል ሴንተር ኦፍ ባላንስ ወይም ደግሞ ሴንተር ኦፍ ግራቪቲ እንዴት ማግኘት እንደሚችል አይተናል ማለት ነው። እዚህኛው ቻፕተር ሶስተኛ ቻፕተር ላይ ከኤርክራፍት weight and balance ጋር እንዴት እናያይዘዋለን የሚለው ነው የምንሰራው ማለት ነው። ፎር ከዚህ ከሶስተኛ ቻፕተር በኋላ ያሉ ሁሉም ቻፕተሮች ስለ ኤርክራፍት ዌይት ኤንድ ባላንስ ካልኩሌሽን ነው የሚያተኩሩት ማለት ነው፣ እንዴት እንደሚሰራ እና እሱን ነው የምናተኩረው እዚህ ቻፕተር ላይ። ሪኳየርመንትስ ኖርማሊ ህግ አያስገድደውም። ሁልጊዜ በየጊዜው ያው የተወሰነ ዲስከስ እንዳደረግ ነው ሁልጊዜ ዌይት ኤንድ ባላንስ እንዲሰራ አይገደድም። አንድ ኤርክራፍት አምራቹ ወይም ደግሞ ማኑፋክቸረሩ በሰጠው ዳታ መሰረት የአንድ ኤርክራፍት ዌይት ኤንድ ባላንስ ይታወቃል። አንለስ ኤንድ አዘርዋይስ ምን ሲሆን ማለት ነው በዌይቱ ወይም ደግሞ በአጠቃላይ ኤርክራፍት ዌይት ኤንድ ባላንሱ shift የሚያደርግ ሜንቴናንስ ወይም ደግሞ ሪፔር ወይም ደግሞ የኢኩዊፕመንት ቼንጅ ካልተደረገ በስተቀር በየጊዜው ዌይት ኤንድ ባላንስ አይሰራም በመሰረቱ ማለት ነው። There is data which is given by the manufacturer or by the certification provider. certificate በሚሰጠው አካል የተዘጋጀ ዶክመንት አለ ማለት ነው። based on that document ነው የሚሰራ እንጂ ሁሌ weight and balance አይሰራ ማለት ነው። ይሄ አይተናል ማለት ነው። So such aircraft are usually weighed when originally certified or after major alterations are affected. ስለዚህ አፌክት የሚሆነው ያው ሜጀር የሆነ ቼንጅ ኤርክራፍቱ ላይ ከተከናወነ ነው የሚል አይተን ነበር። ፎርስ የኤርክራፍት ዌይት ኤንድ ባላንስ መስራት አስፈላጊነት አንዱና ዋናው ደግሞ ምንድነው ሴፍቲ ነው። ኦፍ ኮርስ አቪዬሽን ላይ ቅድሚያ ከሚሰጣቸው ነገሮች አንዱ ምንድነው የሴፍቲ ጉዳይ ነው ማለት ነው። ይሄ ማንም ሰው የሚያውቀው ነው ማለት ነው። ሶ for the purpose of safety ኤርክራፍት ዌይት ኤንድ ባላንስ ሲሪየስሊ ይታያል ማለት ነው ዋና ዓላማ። ሶ ይሄኛው እነዚህ አይተን ነበር። for the major source of weight and balance change ሊሆን የሚችለው ምን ሲሆን ነው ብለናል? ሪፔር ኤንድ አልተሬሽን ስንል ምንድነው ጊዜ የሚፈጥራቸው የተለያዩ ኢኩዊፕመንቶች አሉ which are smart or low in very light in weight but they have many of the equipments integrated within it. የተለያዩ ሲስተሞች እና የተለያዩ ፈንክሽን የሚያደርጉ የተለያዩ ኢኩዊፕመንቶች አሁን ማምረት ተችሏል ማለት እንደምታውቁት ቴክኖሎጂው እየረቀቀ በሄደ ቁጥር ብዙ ነገሮች በቀላሉ ፈንክሽን የሚያደርጉልን ኢኩዊፕመንቶች ሲስተሞች እና የተለያዩ እንትኖች ማምረት እየተቻለ ስለሆነ የክብደቱ በዛ ልክ የቀነሱ ነገሮች ኢኩዊፕመንቶች ማግኘት ተችሏል ማለት ነው ከድሮ አውሮፕላኖች ለየት ባለ መልኩ። ሶ የድሮ ቀደምት ምርቶች ኖት ኦንሊ አውሮፕላኖች ሌሎች መገልገያ እቃዎች መኪኖች ኤንሶን ሌሎችም ኢቭን ቴሌቪዥን እና የመሳሰሉ ራሱ እንደምትታዘቡት በክብደታቸው እና በሚይዙት ኤሪያ ያነሱ ነገር ግን ያው ፈንክሽናቸው የድሮ እቃዎች በቀላሉ ፈንክሽን የሚያደርጉ ኢቭን ተጨማሪ ፈንክሽን የሚያደርጉ ማምረት ይችላል። በዚህ ምክንያት የተለያዩ አልተሬሽኖች ወይም ደግሞ ኢኩዊፕመንት ቼንጆች በሚደረግበት ሰዓት የኤርክራፍቱ ዌይት ኤንድ ባላንስ ሊቀየርብን ይችላል ማለት ነው። during this time we have to make what record of this alteration and make another weight and balance record መያዝ አለብን ይኖርብናል ማለት ነው። ዋናዎቹ የዌይት ኤንድ ባላንስ ቼንጅ እነዚህ ሁለቱም ነገሮች ሲሆኑ otherwise ግን ያው አንድ ኤርክራፍት ዌይት ኤንድ ባላንሱ ተሰርቶ ሬዲ ሆኖ ነው ወደ ኦፕሬተሩ ወይ ደግሞ አውሮፕላኑ ኦፕሬት ወደሚያደርገው አካል የሚደርሰው ማለት ነው። እነዚህ አይተን ነበር last time. So today our today's topic is about equipment for weighing ወይም ደግሞ weight and balance ለመስራት የሚያስፈልጉን equipments ምናምን ማለት ነው። Weighing aircraft with accurately calibrated scales is the only sure method of obtaining an accurate MPT weight and CG location. So the main purpose of weight and balance በሚሰራበት ሰዓት normally it is about obtaining the MPT weight of the aircraft and the location of the center of gravity of the aircraft ማግኘት ነው ማለት ነው። So there are equipments which help us to perform this weight and balance activity accurately ማለት ነው. And these equipments are accurately calibrated scales as you can see in this picture. So based on the type of aircraft there are different type of weight and balance performing equipments or supporting equipments. The two basic types of scales used to weigh an aircraft are platform and electronic load cell የሚባሉ ሁለት አይነት scales አሉ on the airfield or in the runway on the airport otherwise. ስለዚህ እነዚህ ኢኩዊፕመንቶች አሏቸው እነዚህ ግራውንድ ሰፖርት technicians and of course technically we call them flight dispatchers. እነዚህ እቃዎች ይኖራቸዋል based on the type of aircraft of course. There are two basic types of scales which are used to perform the weight and balance activity. So platform scales as you can see in this figure or ramp wheels also we call them. They usually a form of modified version of a platform scale. This ramp wheel ምንለው ሁለተኛው ፊገር ማለት ነው። ይሄኛው ፕላትፎርም ሁለተኛው ፊገር ላይ this one ramp wheel. So this is of course modified type of this platform are low profile, easy to handle and safe. And also reliable. The data or the information they give us is very reliable and the equipments are easy to handle. As you can see they are easy to handle. So this platform, as you can understand from the name also, this is a platform or a flat something plate. So the aircraft's main wheels or landing gears will be here and data will be delivered through the cable and you can read it from this equipment. So how this is performed, you tow or push the aircraft wheels or skids onto the scale pad at the ground level. First, the place where the aircraft's weight and balance will be performed should be level and straight. You must check that one. Then you push or you tow the aircraft and put it on this scale. So with one scale per wheel, so the first scale, one scale will be on one of the wheels and the other on the step by step you will perform on all the landing gears or the aircraft wheels. So with one scale per wheel, each device should be capable of measuring up to 60,000 pounds of, since the weight on each wheel rarely exceeds this figure. So እያንዳንዳቸው ዊል ላይ ከዚህ ኤክሲድ ሊያደርግ ስለሚችል እስከዚህ 60,000 ፓውንድ የሚያህል ሜጀር ያደርግልናል አንዱ ላይ ማለት ነው። then we record and we perform our weight and balance procedure based on the procedure given. So electronic load cell scales the other type of equipment is this type of equipment, and it's called electronic load cell. So they are also reliable means of weighing aircraft and are typically cheaper than the platform type. In terms of cost, this one are cheaper. Using load cell scales allows for the aircraft to be set up and weighed in its level of flight altitude. With this method, the aircraft is placed on jacks. Unlike the previous one, or the previous type of aircraft weighing equipment, in this type of equipment, the aircraft will be placed on jack. As you can see, this is jack or hydraulic jack, or በተለምዶ ምንድነው የምንለው ክሪክ የሚባለው ማለት ነው። ሶ ክሪክ መኪና ማንሻ ክሪክ ማለት ነው። So the aircraft should be on jack when we are using this type of weight and balance calculation. So the aircraft should be on this jack. So using the load cell scales allows for the aircraft to be set up and weighed in its level flight attitude. So the aircraft should be in its level flight, and based on the procedure, the weight and balance will be performed when the aircraft on the jack. With this method, the aircraft is placed on jack with the electronic cells placed between the jack and the jack pad on the aircraft. So the electronic pad will be here, or at the jack point of the aircraft, and data will be transferred similar to the one. So we will read on a display regarding the weight and balance. So as you can see in this picture, this helicopter is on the jack, and there is an equipment which is known as electronic load cell scale. A load cell is placed at the jack point. So the point where the jack will be spotted is the jack point of the aircraft, and through this cable we will read the data from this. So data which is available for our weight and balance calculation will be read from this display. So this is the electronic type of weight and balance equipment. The aircraft is raised on the jack until the wheels or skids off the floor. Of course, when we put the aircraft on jack, there are procedures normally. So the aircraft wheels or the landing gear should be clear from the ground normally, or on the air. Only the jacks should hold the aircraft on its position. So the weight measured by each load cell is indicated on the control panel of the equipment. The jacking an aircraft off the ground from all load points can be an inconvenience as well as a safety risk, which some operators would rather avoid by opting for more expensive but simpler to use platform equipment. So in terms of safety, the platform type of equipment is preferred because jacking an aircraft by itself has its own risk related to safety. Untitled Chapter has a question. What is the difference between load cell and electronic load cell? So we have discussed about this. I appreciate this type of communication, by the way, during our class. So Untitled Chapter asked a question: the difference between the two type of equipments which are used for measuring or for performing weight and balance. So these are the two types of weight and balance. For example, this electronic load cell, we have said there is a jack point, or the aircraft should be on the jack when we use this type of this type of equipment for our weight and balance. Whereas on this platform, the aircraft wheels or the landing gear will be here on this platform or on this plate. ይታያቸዋል? So the wheel will be here when we use this type of scale or equipment for weighted balance. Whereas when we use this electronic load cell, the aircraft should be clear off from the ground by using the jacks or hydraulic jacks. So the main difference is this one, but they are of course similar. And the cable will be where? Or the data cable, that means, will be on the jack point of the aircraft. So that the data will be delivered to the display ማለት ነው based on this. Clear ነው? ግልጽ ነው? ናትናኤል ተመልሶላል?
እኔ የጠየቅኩት የሎድ ሴል እና የኤሌክትሮኒክ ሎድ ሴል ልዩነቱን ነበር ማለት ሎድ ሴል
ሎድ ሴል እና ኤሌክትሮኒክ ሴል where are load cells? ኤሌክትሮኒክ ሎድ ሴል ነው ያልከኝ። ኦኬ ፕላትፎርም ኤንድ ኤሌክትሮኒክ ነው ኤክስፕሌን ያለው። ሎድ ሴል ኖርማሊ is another expression for the electronic ባጭሩ ያገላለጽ ነው እንጂ ሎድ ሴል ኤሌክትሮኒክ ሎድ ሴል እዚህ ስለተጠቀምነ ነው። So load cell, electronic load cell, the same matter of expression. Sorry, ጥያቄ ያኛው ስለመሰለኝ ነው። So ተመልሱልሃል አሁን አይደል? የኤክስፕሬሽን ጉዳይ ነው እንጂ they are the same. But I thought your question was between the two type of equipment. Okay. So jacking an aircraft off the ground, it should be clear off from the ground, so it has some aspect or some aspect related to safety. So in terms of safety, this will be preferred. In addition, weighing with platform scales typically takes only 1/3 of the time. So in terms of time economy also, this platform scale is more efficient than the electronic load cell type of equipment. So this one is also, in terms of time, it's 1/3 of time. 1/3 of the time which will be taken by this one will be consumed by this. So in terms of time economy, this is more faster than the electronic load cell one, or it's preferred. All skills for aviation use, manual or operation, whatever, they must be used, they must be protected with or shipped with safety. Of course, you are already aviation personnel, you are joining aviation, so any equipment which is related to aviation, of course, not only aviation, but we are talking about aviation, so any document or manual or electronic equipment must be protected when stored or shipped, and they must be checked periodically. So this equipment is in order to work properly or in order to be used for a longer time, they should be stored according to procedures and to rules. So ማንኛውም ዕቃ ከአቪዬሽን ጋር የተያዘ በጥንቃቄና በደህንነት መያዝ አስፈላጊ ነው። በተጨማሪ ደግሞ ፔሪዮዲክ የሆነ ቼክአፕ ማኑዋሉና ወይም ደግሞ የኦፕሬሽን ማኑዋሉ በሚያዘው መልክ መሰረት ፔሪዮዲክ የሆነ ቼክአፕ ማድረግም አስፈላጊ ነው ማለት ነው። ለሴም ትዛዝ እነዚህ አሁን ያልናቸው ኢኩዊፕመንቶች they should be stored properly after completion of jobs or tasks, and they should also be checked periodically even if we are not using them for a longer time. If they should be stored according to the procedures which are provided within the operation manuals. The maximum recognized period between calibration checks is 12 months. For example, if you don't use your electronic equipment or the platform type of equipment for 12 months in an activity, you should go and check for its proper calibration every 12 months. However, this period may be also reduced by an airworthiness authority dependent on the condition of use. Of course, it can vary based on the direction which you are provided by the responsible authority. But at least for each equipment, you have to check for at least 12 months. After 12 months, periodic የሆነ ቼክአፕ አስፈላጊ ይሆናል ማለት ነው። Scales in the daily use may require a shorter interval and or daily, of course. Daily የምንጠቀምባቸው equipment we may require to check every 6 months or 5 months or even 3 months we may. But those equipments which we don't use them periodically, we should at least check them within 12 months minimum. Scales should be returned to the manufacturer for proper calibration testing, of course. Any scale, gauges and other equipment which are used in the aviation maintenance environment, they should be returned to calibration stations or calibration centers based on the requirement. So preparation for weighing. In general, weight procedures may vary with the aircraft and type of weight equipment employed. ጠቅለል ባለ መልኩ ስናየው የምንከተለው ፕሮሲጀር ለኤርክራፍት ዌይት ኤንድ ባላንስ ከአንድ ኤርክራፍት ወደ ሌላ ኤርክራፍት ሊለያይ ይችላል። of course also based on the weight equipment we use equipmentum የምንጠቀመው መሰረት በማድረግ ሊለያይ ይችላል። but in general ግን ያው የምንከተላቸው ፕሮሲጀርስ ግን for every aircraft they are almost the same ማለት እንችላለን። ነገር ግን ከአንድ ኤርክራፍት ወደ አንድ ኤርክራፍት ግን የሚለያዩ የተወሰኑ ነገሮች ሊኖሩ ስለሚችሉ we have to follow the document, the proper document for that specific aircraft ማለት ነው። so አንዱ የፈርስት ስቴፓችን when we are preparing to make aircraft weight and balance, our first step is to get or to make ready the proper document related to that particular type of aircraft weight and balance. ከኤርክራፍቱ ጋር የተያያዘ proper document ማግኘት it will be our first procedure. The weight procedure contained in the manufacturer's maintenance manual should be followed for each particular aircraft. Of course, ከአሁን በፊትም ዲስከስ እንዳደረግናቸው including not only this document which is related to weight and balance, which is our topic for today, የሁሉም ሲስተሞች የሃይድሮሊክ ሲስተም have discussed in the first semester, landing gear, control system and so on, እያንዳንዱ document you have to get them within the aircraft. So the weight and balance procedure contained in the manufacturer's maintenance manual should be followed for each particular aircraft. The major consideration in preparing an aircraft for weighing are described in the following slide. So the first step is we should prepare the scale. Which type of scale we are using, you should prepare it. So mechanical and electronic scales should be inspected prior to use and set to 00 ላይ ሴት ይደረጋሉ። of course ይሄኛው የተለያዩ ስራ ላይ ኤክስፒሪየንስ ያላችሁ በተለይ ከሆናችሁ ያው ምንም የተለየ ነገር አይኖረው ማለት ነው። this equipment should be set to 0 መጀመሪያ ጌጅ የመኪና ጌጅ ለምሳሌ ስፒዶሜትር or whatever ወደ 0 ሴት እንደሚደረገው this scale should be also 0 should be set to 0 before we start our weight and balance procedures. This is done by adding and removing a weight, then rechecking for 0. So የራሱ ስቴፕ በመከተል 0 እናደርጋለን ማለት this process should be repeated until steady 0 is obtained. The scale should be located in the same environment in which they are to be used and allowed to come up to temperature at least 2 hours prior to use. So ወደ 0 ስኬል በምናደርግበት ሰዓት somewhere different የሆነ ቴምፕሬቸር ያለው ወይም ደግሞ different environment ላይ ሆነን አይደለም ሴት የምናደርገው somewhere hot የሆነ ኤሪያ ላይ ሳይሆን ሜዠርመንቱ የምንሰራው ወይ ደግሞ ዌይት ኤንድ ባላንስ የምንሰራው ኤሪያ ላይ ሆነን ነው መስራት ያለብን ማለት ነው። ኦፍ ኮርስ ኦልሶ the temperature difference used allowed to come up to temperature at least 2 hours prior to use እስከ 2 ሰዓት የሚሆን ቀደም ብሎ መዘጋጀት አለበት ማለት ነው። Scales should not be used in temperature extremes between below 40 degree Fahrenheit or above 100 degree Fahrenheit unless the scale is specifically designed for use in these temperatures. So ከዚህ ቴምፕሬቸር ሬንጅ ውጭ ከሆነ እንዲህ አይነት ስኬሎች መጠቀሙ አይመከርም ማለት ነው። because it will create some kind of error ሊፈጥርብን ስለሚችል ማለት ነው። Electronic scales are very sensitive and if subject to freezing temperatures the liquid display may be damaged beyond use. So the first step is to prepare your scale based on these procedures. The second is weigh clean aircrafts inside hangar. So the aircraft should weight and balance should be done also inside a hangar. Hangar ላይ ነው መሰራት ያለበት ምክንያቱ outside environment there is wind or other rain or whatever conditions can create or can cause an error to our weight and balance calculations. So it is advised or it is recommended to work this weight and balance calculation of an aircraft inside hangar ላይ እንዲሰራ ይመከራል። So the aircraft should be weighed inside hangar where wind cannot blow over the aircraft surface and cause fluctuating or forced scale readings. The aircraft should be clean inside and outside with special attention paid to the bilge area to ensure that no water or debris is trapped. The outside of the aircraft should be as free as possible of all mud and dirt. የተለያዩ አላስፈላጊ ውጫዊ ኤጀንቶች ላይክ መድ እና ዳርት የመሳሰሉ ነገሮች ደግሞ ክሊን መደረግ አለባቸው ማለት ነው። the third one is the equipment list. All the required equipment must be properly installed and there should be no equipment installed that is not included in the equipment list. There are list of equipments therefore those equipments should be installed on the aircraft should be installed prior to making our weight and balance calculations. Also, if there is another equipment which is not in the list of equipments for weight and balance, it should not be included or should be avoided first from the aircraft. If such equipment is installed, the weight and balance record must be corrected to indicate it, of course. If an equipment or some other weight is installed in the aircraft, this should be considered. This should be taken into consideration and the weight and balance should be performed based on this additional weight. Ballast is kind of weight normally which is installed on aircraft to make the weight and balance of an aircraft balance correct ለማድረግ የምንጠቀመው weight additional weight ነው ማለት ነው። So all required permanent ballast must be properly secured in their proper place. So all temporary must be also removed. Temporary እና permanent blasts ምንላቸው ነገሮች አሉ ማለት ነው። እነዚህ ብላስቶች these permanent blasts they are provided by the aircraft manufacturer of course, but sometimes we can also put a temporary ballast to make our aircraft balance and weight to the desired or the required limit. To the required limit ላይ እንዲሆንልን we can add some additional weight. So this should be removed, whereas the permanent ones should be placed on their proper position. Because the data or the CG range which will be provided by the manufacturer will be based on the permanent ballasts normally. So these blasts are normally, they are heavy material. They are carried in to hold in the hold of an aircraft, especially one that has no cargo, to give the aircraft increased stability, and this is called ballast. So aircraft to balance ለመጠበቅ some kind of weight can be added to the aircraft. For example, there is one aircraft which is known as, which is I know perfectly, which is known as MiG-21 military aircrafts, which is one of the aircrafts which have been used by Ethiopian Air Force. There is some kind of blast or weight end balance optimization weight installed in the nose section of the aircraft. So this is permanent blast እንለዋለን ማለት ነው። On the other hand, on some aircraft, we may also put a temporary ballast to make our weight end balance to the desired position. So this is another important point or procedure before we start our weight and balance procedures. Standard weights. Standard weights. There are also standard weights established. These are established weights for numerous items involved in weight and balance competitions. This weight should not be used if actual weights are available. For example, if the weight of this standard weight is given, we may not use them actually. But if we are not given, we have some data which is in our flight manual or in the pilot's operating manual, we will get such type of data. For example, this is aviation gasoline at 32 degrees Fahrenheit. It will be 6.14 gallon መሆኑ ይታወቃል in terms of weight. Then how much liter do we have inside the aircraft fuel tank? And also jet A የሚባል type of fuel የሚጠቀሙ, this has 6.7 gallon per liter, of course. And water density, this is density by the way, 8.3, and oil 7.5. So these are the standard weights which are used for data for the weight and balance calculation. Unless otherwise they are specified, we will use this data at this temperature and at this temperature, because by nature, as you know, the temperature will have so fluids and this temperature. Hence, we use this temperature variation. So based on the temperature variations, the type of fluid, which fuel, for example, water or air, we use this data. So some of the standard weights are listed in the following table, of course. So this weight should not be used if actual, in some cases, the actual weight of each standard weight will be given. For example, this amount of water is available, this is. But if we are not given this specific weight for each standard weight, like aviation fuels, water, oil, and so on, we use this table in order to make our weight and balance calculations. So note that the difference in weight as temperature change. So with temperature variation, of course, as you know, by nature, these fluids will vary. So although this change is a very small amount per gallon, of course, per gallon, this is very small actually. It's, you may think it's very small per gallon, per 1 gallon, but as you know, huge aircraft, especially those commercial aircraft, majority of their weight will be taken by these fluids, like fuel, for example, is a very significant part of the weight of an aircraft. So you should not underestimate variation of weight, because 6.14, for example, for aviation per gallon. But as you know, very huge aircrafts, they have to carry huge amount of fuel on their fuel tanks, and it could be the source of weight and balance disorders. So although this change is very small in per gallon, it could end up in a significant total weight gain when dealing with large quantities of fluids, such as those found in the commercial aircraft, for example, ማለት ነው. So you should not underestimate this amount of fuel or fluids, or in general, they are standard weights. The other is draining the fuel. So one of the procedures which should be followed during preparation of weight and balance is you should drain, or you should avoid the fuel within the aircraft. So drain fuel from the tanks in the manner specified. Of course, there is a procedure how you can drain or how you can avoid the fuel from the aircraft. Based on the procedure, you should drain it. If there are no specific instructions, drain the fuel until the fuel quantity gauge reads empty when the aircraft is in level flight altitude. Level flight altitude means the aircraft should be level first. In a level and straight line, attitude መሆን አለበት before you drain. So you should drain. And if you remaining in the system is considered residual or unusable fuel and is part of the aircraft empty weight. So when you are referring to your manuals, you will get residual fuel, and this will be considered as part of the empty weight of the aircraft. The amount of the residual fuel and its armor normally found in the note. Note 1 in the section of the type certificate data. So this residual you will get in the type certificate data sheet. Data pertaining all models of the aircraft. Based on the aircraft, you will get. So we have discussed about this type of certificate, TCDS. So you will get this data also, residual, and its arm also. If it is not feasible to drain, for example, in some cases, you may not able to drain the fuel. So you should follow another technique, that is, you should top up the fuel tank to its maximum level, and then take the measurement based on that. So አንዳንድ ጊዜ ፊውል ሙሉ በሙሉ ድሬን ማድረግ የማይቻልበት ኮንዲሽን ቢፈጠር እንኳን you should fill fuel tank ሙሉ በመሙላት based on the standard data we are here given here, the type of fuel, for example, if you get one, then how much gallon is it times is this liter times its density. You should put the weight which is caused due to this thing, and then you should subtract it from the total weight. So ሙሉ በሙሉ በመሙላት you can make this type of. After weighing is complete, the weight of the fuel and its moment are subtracted from those of the aircraft as weight. So subtracted as the correct, to correct the empty weight for the residual fuel, add its weight and moment. So residual ደግሞ ለመጨመር you should add it. The other is oils. There are different type of oils which are used in the aircraft. Lubricating oils, engine oils, and hydraulic oils, and so on. የተለያዩ አይነት oils አሉ ኤርክራፍት ሲስተም የተለያዩ ሲስተሞች ላይ ማለት ነው። Grease and so on አሉ within the aircraft systems. Therefore, one of the procedure is to consider this oils. You should empty this oils also, or you should avoid or should drain this. The weight for aircraft certified under civil aviation regulation cars this part does not include the engine lubricating oil. Based on the type of aircraft, of course, this may not include. So the oil must either be drained before the aircraft is weighed, or its weight must be subtracted from the scale reading to determine the input weight. So to weigh an aircraft that does not include the engine lubricating oil as part of the weight, the input weight, place it in level flight attitude, then open the drain valves and allow the oil to drain out. Any remaining is undesirable oil and is part of the input weight. So you cannot avoid 100%. Some amount of may remain within the fuel lines, the fuel tank, and other systems. So this can be considered as part of the input weight of the aircraft. And another aircraft which have been certified under this Title 14 called Federal Aviation Regulation include full oil as part of the input weight. Some aircraft may also consider as part of the input weight. So it's the documentation which you are using, which gives you the direction how you can measure or you can proceed your procedures on this weight and balance. So on some aircraft, you should defuel the oils, or you should avoid the oils. On some aircrafts, you may also consider as part of the input weight. So seriously, you should follow the procedures. If it is impractical to drain oil also, the reservoir can be filled, similar to the one we have discussed for fuels, to the desired level. Then specified level, and then the weight of the oil is computed at this pounds per gallon. በአንድ ሊትር 7.5 pounds per gallon በማባዛት you can subtract the weight which is added due to the presence of this oil. Then its weight and moment are subtracted from the weight and moment of the aircraft as weight. The amount and armor of the undrainable oil are found in note 1 of the type certificate data sheet, and this must be added to the input weight. Undrainable, of course, unavoidable, it will be found in your type certificate data sheets. Other fluids also are available. Hydraulics fluids in the reservoirs are other reservoirs containing fluids required for normal operation of the aircraft should be full. ሌሎች, of course, without hydraulic fluid, normally you cannot perform even ground operations. Yes, therefore this hydraulic reservoir should be full according to the procedure, and all other reservoirs containing fluid required for normal operation of the aircraft, they should be full. So fluids not considered to be part of the input weight of the aircraft are potable or drinkable water, lavatory, pre-charge water, and water for injection into the engines. And these are not considered as part of the input weight, whereas this hydraulic fluid is considered in most of the cases, because without this hydraulic fluid, you cannot extract and retract your landing gear, for example, your control surface, and so on. Therefore, this cannot be considered as part of, this can be considered as part of the input weight, whereas some fluids like drinkable water, lavatory water, which is pre-charged water, and water for injection into the engines, and also other fluids, if they are available, they cannot be considered as part of the weight and balance. The input weight configuration of the aircraft. So there should be some known configuration or position of the aircraft for making weight and balance. So you should consult or you should refer your service manual regarding position of the landing gear, shock strut, and other control surfaces for weighing. So during weighing, what type of position or configuration will the aircraft have? It may vary from aircraft to aircraft, so you should consult your service manual. So the landing gear strut should be inserted or retracted and so on. The position of the control surface should be at this angle, at some angle, 10 degrees, something like that. So you should check your manuals related to the position of the aircraft when you perform this weight and balance. So when weighing, one of the procedures is the configuration of the aircraft. So you should consult the document or the service manual for the aircraft, and especially for helicopter, you should focus on the main rotor and they must be in the correct position. The other is jacking the aircraft. So if you are using the second type of equipment especially, so there is a procedure for jacking the aircraft. So aircrafts are weighed by rolling them onto the ramps in the load cells are embedded. So this eliminates the problems associated with jacking the aircraft. So which load cells are embedded? ከስር load embed ከሆነ ማለት ነው። So jacking አያስፈልገንም this time. However, many aircraft are weighed also by jacking the aircraft up and then lowering them onto the scales loads. Clear በማድረግ then መጨረሻ ላይ we can put them or we can lower the jack. So this jacking is one important procedure when we are working the weight and balance of an aircraft. So which needs special attention. So extra care must be used when raising an aircraft on jacks for weighing. If the aircraft has spring steel landing gear and it is jacked at the wheel, the landing gear will slide inward as the weight is taken off the tire, and care must be taken to prevent the jack from tipping over. So you should be sure to follow the recommended or the recommendations of the aircraft manufacturer in detail anytime any aircraft is jacked. Also, not only for jacking, but for other procedures or for other tasks also, you should follow the recommendations which are provided by the manufacturer of the aircraft anytime when you jack up or lower the aircraft or jack down the aircraft. The other is level the aircraft. Level the aircraft should be in its level position before we go for aircraft weight and balance. So this attitude or the level and straight position information is found in your type certificate data sheet. So some aircraft require plumb line to drop from a specific location so that the pilot the point of the weight or the bob hangs directly above the identifiable point. So others specify that a sprit level be placed across two leveling legs, often special screws on the outside of the fuselage. So other aircraft call for a sprit level to be placed on the upper door seal. So there are also equipments which are known as plumb line, which are commonly found on the carpenters also. Also a sprit level can be used to check the level or whether the aircraft is on its proper level position. You can use these are the two equipments. For example, this is the plumb line. ይሄኛው ኢኩፕመንት እንደምታውቁት የተለያዩ ግንበኞች እና የተለያዩ ሙያተኞች የሚይዙት type of equipment ነው. So this is used to check whether the surface is level or not. ቼክ ለማድረግ ይጠቀሙበታል ማለት ነው። Also, this one is the spritz level. Similarly, this is also used by the carpenters also. So you can use them according to the procedures which are found in your documents when you are making aircraft leveling. In fact, this is called leveling. The procedure is called leveling normally. You should leveling or making the aircraft level. So you use different equipment as desired or as required. So these are two equipment. So safety consideration is also another. So we have discussed normally 11 procedures we should be considered when we are preparing to make our weight and balance in our aircraft. So these are the 10 procedures. Of course, there are 11 normally. So the other important thing when we are doing the weight and balance is the safety considerations. Special precautions must be taken when raising an aircraft on jacks. So of course, there are some precautions or safety measures which should be taken when we use our aircraft on jacks also. All jacks have screw down collars, some use drop pins or friction blocks. Based on the type of jack normally, some have down corals, some have drop pins, or some have friction locks. Based on the type of jack, you should follow the procedures. So having said this is a preparation of weight and balance before we make weight and balance. But the ultimate goal of any weight and balance is to get the center of gravity, as we have discussed. So those we have discussed before in the previous few slides are the procedures and the safety precautions which should be taken. But the ultimate goal of any weight and balance calculation is to determine the center of gravity of the aircraft. This one. So when the aircraft is in its level flight attitude, drop a plumb line from the datum and make a mark on the hangar floor below the tip of the bob. So these are the procedures how you can get the desired center of gravity of the aircraft. So you can mark by drawing a chalk or some other marking mechanism, then draw lateral lines between the actual weight points or the minors and make a mark along the limit line at the weighing point for the nose wheel or the tail wheel. This line and marks on the floor allow accurate measurements between the datum and the weighing points to determine their arms. Of course, as we have said in the previous discussions, one of the important parameters which should be considered is which should be found or should be known is the arm, this thing, and the weight also. So determine the CG by adding the weights. Of course, we have discussed also, we add the weights, then you add the moments, and you divide the total weight to the total moment, then you will find the center of gravity relative to the datum. Then divide the total moment by the total weight. And you will get the center of gravity relative to the datum line or to the reference. You will get. So these are the procedures which we have seen in the previous. Well, that time we have discussed only for a lever which is put some kind of weight, but this time we will exactly or we will directly calculate the weight, the center of gravity to an aircraft. For example, this is an example which is given as an example of locating the center of gravity with respect to the datum. So as you can see, which in this case is the firewall. Consider the tricycle landing gear airplane as detailed in table 3. So we have given weighing points, for example, right side seat, left side seat, nose seat. There are 3 seats. Scale of reading, we have read this one. Read. There is tire weight. And there is also net weight, arm of each, and moment. So the sum of the net weight, that tire weight. So this will be the total weight, net weight, this one. So the moment will be the multiplication of the net weight times the R, and you find this one. So the center of gravity will be the CG will be, this will be equal to the moment divided by the weight. Total moment, of course, over total weight. Then we will find this one is the center of gravity. So locating the CG of an airplane relative to the data. For example, this is the aircraft. Suppose this is the aircraft. And we are given the datum here. The datum of this aircraft is this one. And we have measured here. And the data is recorded. Then here. From here also data is recorded. Then we put here. From the scale we read this amount and tare weight. Then finally we'll get this one. So when the airplane is on the scale with the parking brakes off, of course the brakes should be off, by the way. There should not be brake placed on the chocks. Place chocks around the wheels to keep the airplane from rolling. Of course, brake should be off. Instead of that, there should be a chuck. I mean chocks or taco. Taco የምንለው ነገር ሊኖረው ይገባል to keep the airplane from rolling forward and rearward. Then subtract the weight of the chocks called tare weight. So the weight we call in the previous table this one. This is called tare weight, this one. This is the chuck weight or choke weight ማለት ነው። የቾክ ወይም ደግሞ የታኮ weight ማለት ነው። So if you use this one, subtract the weight of the chocks minus the tare weight or the choke weight, you have to subtract because it's 830 can be found by subtracting 16 from 846. So this is subtracted. Therefore, this is the tare weight or the weight due to the introduction of these chocks. አድ በማድረጋችን ምክንያት የራሱ የሆነ weight አድ ማድረጉ ስለማይቀር we subtracted, and this will be found in your books or data books from the scale reading to determine the net weight at the weighing point. Then we multiply each weight by the arm, as we have discussed in the previous theory of lever. Then we multiply by the arm, then we add total moment to find, we add this multiplied products to find the total moment and then determine the total weight and total moment. Then the CG is determined by dividing the total moment to the total weight, as you can see here. So this is the center of gravity, total moment divided by total weight. And the center of gravity for this particular aircraft is 32.8 inches behind the datum. Behind the datum means to the right of the datum, because this is positive. If this is positive, it is to the right, and if it is negative, this will be to the left. Therefore, the airplane in the table has net weight of this amount of power, and the CG is this amount. So this is the aircraft with the datum here. So you'll be given a datum is any vertical line which passes through the aircraft. It can be somewhere, arbitrary line normally, in the nose, in the tail, anywhere. Then this is the datum located at the firewall. Of course, this datum is given to be at the firewall of the aircraft. And finally, you will get the center of gravity by using this formula. Center of gravity, total moment over total weight. So you'll get this is the CG. And also you will find the range within which this center of gravity can be tolerated. So you'll get from your data the range of the center of gravity, and then you will load your aircraft according to this limit, or to the center of gravity range, or center of gravity limit. Then you will make ready your aircraft for flight, or you will dispatch it, because those personnel who are working here are called flight dispatchers or aircraft dispatchers. So another is input weight formulas. So input weight formulas, there are charts, as we have seen this one. Table 3 means this one. Charts like this one helps the pilots to visualize the weights, the arms, and the moments which are created by this weights. በእነዚህ weighቶች ምክንያት የሚፈጠር ሞመንት ምን አይነት weighቶች አሉ ኤርክራፍቱ ላይ the pilot will be assisted by the data which will be provided by the personnel working on the ground, but it is quicker to determine the input weight CG by using formulas and an electronic calculator. So these charts or these data which are provided in hard copies to the pilots will help him what type of weight is installed or loaded on the aircraft, and at what arm it is installed, and how much amount of moment this will create, and how it will affect the controllability of the aircraft. Visualize እንዲያደርግ ያግዙታል ማለት ነው የሚሰጡ ዳታዎች። In fact ግን በትክክል there is some quicker mechanism where we can also determine the empty weight center of gravity of the aircraft by using formulas and electronic calculators also. በመጠቀም ካልኩሌት የሚደረግበት እድልም ግን አለ ማለት ነው። So the use of calculator for solving this problem is described in chapter 8 aircraft weight and balance handbook. This is our textbook normally. How to calculate the input weight using calculator. Input weight CD, it will be discussed in chapter 8 of our textbook. Also, this topic, use of computers in weight and balance competitions, በሚል chapter አለ ማለት ነው። So we will see it in the next chapter 8. Or also, if you are interested and hurry to know this, in urgency to know this calculation, how to make calculations by using computers and calculators, you can go to your textbook and refer chapter 8 or read. So in that chapter, there is a chapter 8, which is use of computers in weight and balance competition. But in this topic, we'll see empty weight calculations by using formulas. There are also formulas where we can find, through which we can find the center of gravity. So there are, as we have said earlier also, I said it several times, the ultimate goal is to get the center of gravity, by the way. The center of gravity of the aircraft based on the weights which are on the aircraft. So there are 4 possible cases in any aircraft. When we use this formula method to get the center of gravity, there are we have 4 possible cases. The first case is, of course, all these 4 cases are based on the location of the datum. The first case, for example, the datum is forward of the airplane nozzle. The second is datum aft of the main wheels. The third one, tail wheel landing gear. And the fourth one is datum aft of the nose, that is the tail wheel landing gear. Tail wheel, both of this one are the nose wheel type of aircraft, and this type of the tail wheel aircraft. Of course, this one we have discussed what type of aircraft we call nose wheel and what type of we call tail wheel. We have discussed in the first course about aircraft systems and structure. Nose wheel, where majority of the aircraft is. Majority of the aircraft is loaded on the nose wheel. በሚሆንበት ሰዓት we call such type of aircraft majority load here, nose wheel. Nose wheel የምንለው aircraft ይሆናል ማለት ነው። In some aircraft also, majority of the aircraft load is concentrated on the tail wheel. Such type of aircraft, we call them tail wheel እንላቸዋለን ማለት ነው። Therefore, we will see these 4 cases to calculate the center of gravity by using formulas. So let's see the first case. Of course, by completing these 4 cases, we will wind up our today's discussion normally. So the first is datum forward of the airplane, or this type of aircraft is, of course, is a nose wheel type of aircraft, as you can see. So the difference between the nose wheel and the main wheel is that majority of the aircraft is loaded. The aircraft load is carried by this nose wheel. So let's see. So here we have the datum is forward of the airplane. So here we have the data. So to determine, in general, of course, we will have center of gravity to be is equal to plus or minus d plus or minus the force times L over the gross weight of the aircraft. This will be, in general, the formula for all the aircraft CG calculation based on the formula. So what are these parameters for? D is the distance between the datum and the main wheel. The wheel. Here is the wheel. D is the distance between the datum and this wheel. Force. The datum of the airplane in figure 7 is 100 inches forward of the leading edge of the route. Let's see let's see the formula first anyway. So this is the distance of the main wheel from the datum. So D is this one. L is the distance between the 2 wheels, between the main wheel and the nose wheel. F is the weight of the nose wheel. F is the nose, weight is the total weight of the airplane. This is the CG location. Therefore, F is the nose wheel. Nose wheel landing gear is in consideration. So here is the force F here. This is our F. So our calculation will be based on this data. So from this, relative to this, what will happen to this? So we are going to calculate the CG based on this formula. Plus or minus D minus, plus or minus, of course, FL over weight. Then we will calculate, for this case, we will calculate the CG is equal to B. So this is the D. D is to the right of the datum, and hence it is positive. So this is plus D ይሆናል ማለት ነው። then this plus or minus, we don't know. So which one? This force. This force. This is this force. This force, it is also causing a moment which is counterclockwise. This force is creating a counterclockwise moment, hence it is negative. That is force times L, the distance between the two, divided by the weight. So for this case, the formula to find the CG of the aircraft is this one. D plus FL minus positive D minus FL over weight will be because the moment which is created by this force. So nose wheel landing gear now. The force in consideration is the wheel on the nose wheel. That is F is in this lying in this nose wheel and here's the total weight of the airplane is found, of course. We find the CG formula of such type of configuration, or in this type of case, when the datum is forward of the airplane, we'll use this type of formula, this formula. So to determine the CG by using the formula below, you will get D minus FL over it, and you will get this one. So the CG is 114.8 inch. And in general, for such type of configuration or position, when the datum is forward of the aircraft, you use this formula. By using it, you will find this. So the CG is found to be by using this formula this much. So this is 13.0 inch forward of the main wheel, weighing pointers, which proves the location of the datum has no effect on the location of the CG if all measurements are taken from the same location, by the way. They should be taken from the same location. But the position of datum has nothing to do. We have discussed also. The second case is when the force in consideration is nose wheel landing gear, of course. The force is the same on the nose. F is here. The force is here. But this time the datum is after the main landing gear. ከላንዲንግ ጊሩ በስተጀርባ ነው ኮንሲደር ማለት ነው። So of course ቅድም ዲስከስ ለማድረግ እንደሞከረው ኖዝ ሂል ኤንድ ቴይል ዊል የሚባለው ኤርክራፍት we have classified based on the load. But in this case, when we took nose wheel landing gear, we are considering the force is lying on the nose wheel. Nose wheel ላይ force, the force we are considering is lying on the nose wheel ማለታችን ነው. Okay? So we are considering the force we are considering is lying on this nose wheel. For this case, እስኪ ሞክሩት based on this one. CG will be ይሄኛው ጻፉ እየሰማችሁ ነው I hope. D plus or minus F times L over weight. ይሰማል ተማሪዎች? ሄሎ so እሺ then try this one. ይሄኛው ነው basic formula, this one. So based on this we have done or we have found this formula for an aircraft where the datum is in front of the aircraft. So for this particular aircraft, then the datum is as a rear of the main wheel. So you can do this CG is equal to, okay. So here is the force. So ምን ይሆናል? Can you tell me? CG is equal to what will be D? D is the distance of this main, this force. የኛው በሁለቱ መሃል ማለት ነው. This is D. The distance of the force. Sorry. This is not. D is this the distance between the main wheel and the datum. Yes, this is D. D. So it is to the left of the datum. D የት ነው ያለው? Is plus or minus? It will be minus D. Because it is to the left of the datum. ስለሆነ ማለት ነው። ይሄኛው plus or minus ነው የሚሆነው. Okay, let's leave it. Plus ነው ወይስ minus? We don't know. Plus or minus ነው የሚሆነው ማለት ነው. Then FL this force times this distance between the two wheels. This one is L divided by weight. No ማለት ነው. Then the moment which is created by this force, by this F, about this datum ነው consider የምናደርገው. It will be counterclockwise አይደል? Counterclockwise type of rotation or moment will create, then it will be minus ይሆናል ማለት ነው. Therefore, for this particular case, the CG will be, for this particular case, the CG formula will be what? CG is equal to minus D minus FL over total weight, or otherwise CG will be negative D plus FL over weight. Of course, እንደዚህ እንደሚሆን I hope. Yeah.
ሌንግዝ የኤል ሌንግዝ ኔጌቲቭ አይደለም እሱን ኔጌቲቭ አንወስድም
አንወስድም because it's no, we are not considering relative to the datum አይደለም እሱ ኮንሲደር ያደረግ ነው ያለነው relative to datum ቢሆን ኖሮ ከዚህ ነው የምንጀምረው ማለት ነው ይሄ ግን በሁለቱ ዊልስ መሃል ያለ ዲስታንስ ብቻ ነው የወሰድነው therefore it's positive L. It's just a measurement ማለት ነው የምንወስደው so relative to the datum ቢሆን ግን is of course to the left to negative እናደርገው ነበር ግን we are only taking the distance between the two wheels wherever position ይሁን ይሄ datum ላይናችን የትም ይሁን it's positive measurement ነው የምንወስደው ማለት ነው because it's a distance between the two only gap ስለሆነ የምንወስደው ማለት ነው ለዛ ነው therefore it will be this one ግልጽ ነው ሀብቴ
አዎ ቲቸር ከዳተሙ አንፃር አስቤው ነው እንጂ የሁለቱ ዲፈረንስ እንደሆነ አልተረዳሁትም ነበር ለዛ
ተከከለ ሌሎቻችሁ ግልጽ ነው ተማሪዎች if you have any question ሁለቱም ፎርሙላ ድራይቭ አድርገናል ማለት ነው so the CG location የተሰጠን ዳታዎች በመጠቀም then we will find we will use this formula for this particular case anyway if the datum is at the back of the main wheel corner main landing gear or main wheel corner ማለት ነው the CG location will be then this one it's negative መጣ ማለት ነው this means negative the CG locationችን it is negative 88.2 ነው ያለን ማለት ነው if it's 88.2 minus this means it is to the left of the datum we select ማለት ነው datum ከመረጥ ነው ወደ ግራ አቅጣጫ እንደሚሆን ነው የሚያሳየን ማለት ነው then this place is 13.8 forward of the main wheels exactly the same location as when it was measured from other datum location so ከሌላ datum location calculate ስናደርገው ቀደም the same ነው የመጣ ማለት ነው so datum is any reference line by the way and it doesn't matter the location of the datum doesn't matter the CG location will be the same ይሆናል for some specific particular type of loading ያለው አንድ aircraft whether we take forward of the nose section or aft of the nose section or somewhere in the aircraft there will not be variation on the center of gravity as far as we take all the measurements from that particular datum So location of datum, the location of the datum is not important in this time. It's not very important. But all the measurements must be made from the same location. For one particular calculation, ከአንድ ቦታ መውሰድ ግን ይኖርብናል ማለት ነው። ግልጽ ነው አይደል? Of course, if I hope እነዚህ ሁለቱም ብንጨርስ ዛሬ ማለት እንችላለን። anyway እስካሁን ያለው you can read it's enough normally for today. ለዛሬ ሊበቃን ይችላል። ጥያቄ ካላችሁ ቴክስት ማድረግ ትችላላችሁ፣ በድምጽ መጠየቅ ትችላላችሁ። እስካሁን ዲስከስ ካደረግናቸው ነገሮች
ልዩነት መፍጠር ዓላማችን ነው። ዓለም አቀፍ ተወዳዳሪ መሆን አለባችሁ። የናሽናል ኤርዌይስ እህት ኩባንያ ናሽናል አቪዬሽን ኮሌጅ ጥራትና ደረጃውን የጠበቀ ስልጠና በመስጠት ብቁ ዜጋ እያፈራን ነው። በፍላይት ኦፕሬሽን፣ በበረራ መስተንግዶ፣ በቲኬቲንግና ሪዘርቬሽን፣ በሆቴልና ቱሪዝም ሙያዎች አሰልጥነን ተወዳዳሪ እናደርጎታለን። ኮሌጃችን ካናዳ ከሚገኘው ኢንተርናሽናል ኤር ትራንስፖርት አሶሲዬሽን አያታና ከእንግሊዙ ICM ጋር በመተባበር ዓለም አቀፍ ዕውቅና ያለው ስልጠና እየሰጠ ይገኛል። በፍላይት ኦፕሬሽን፣ በበረራ መስተንግዶ የምንሰጣቸው ስልጠና ከኢትዮጵያ ሲቪል አቪዬሽን ባለስልጣን ሙሉ ዕውቅና አለው። አድራሻ ከጎላጉል ታወር 22 አደባባይ ወደ ሾላ በሚወስደው መንገድ ላይ የናሽናል ኤርዌይስ እህት ኩባንያ ናሽናል አቪዬሽን ኮሌጅ ህልሞን